Well, this is the video for 6.1 to 6.3 study guide. Alright, number 1 says find the domain of the rational function. So remember, when you're talking about domain, you want to set the denominator equal to 0 and then find out what x cannot be. So I'm going to add 9 to both sides. You get x is 9. So if I were to plug 9 in for x, I would get 0 in the denominator. And we know that's a no-no. So remember, your answer is this. X is the set of numbers such that x is a real number and x cannot be 9. So you take whatever number you get when you set it equal to 0, and that's what x cannot be. Alright, so in order to simplify the rational expression, you have to factor the numerator and factor the denominator. And then you see if anything can cancel. So in my numerator, I can factor out a 5, leaving me behind 5 minus x. In my denominator, I can factor out a 3, leaving me 5 minus x. Your 5 minus x's cancel, leaving you 5/3. And that is your simplified answer. Okay, so same thing here. You're going to have to factor the numerator and factor the denominator. So my numerator is x squared plus 11x plus 30. So it's going to be x and x plus plus. Factors of 30 that give me 11 are going to be 6 and 5. So this is going to be my new numerator. And then the denominator is x squared plus 12x plus 35. Factors of 35 that give you 12 are 7 and 5. So that's going to be my new denominator. So when I rewrite this, I do x plus 6 times x plus 5 over x plus 7 times x plus 5. Your x plus 5's cancel, leaving you x plus 6 over x plus 7. Alright, so here we're simplifying again. The numerator, we're going to have to use roller coaster. The denominator is actually already factored. So if I do x cubed minus 64, I'm going to have to do roller coaster. So remember, small parentheses and then large parentheses. 1 brave soul comes to the front, 2 go to the back. 1 brave soul comes to the front, 2 go to the back. And remember, it's a 4 on each one of these lines, so it's 4 times 4, which is 16. What's a roller coaster without loops? So 4 times x is 4x, and then you're going to scream or puke. So same sign, opposite sign, positive. So my new numerator is x minus 4 times x squared plus 4x plus 16. And we know my denominator is 4 minus x. Well, x minus 4 and 4 minus x are not the same thing. So I'm actually going to go ahead and factor a negative 1 out of the denominator, which would give me negative 4 plus x. And then if I were to rewrite the order, this would be x minus 4, which is what we're looking for to cancel something in the numerator. So those cancel, and you're left with x squared plus 4x plus 16, and it's over negative 1, but you're not going to leave it like that. You can just bring the negative out front, and then you want to go ahead and distribute it. So it's going to be negative x squared minus 4x minus 16. And that's going to be your final answer on that one. Okay, multiply or divide as indicated. So you need to factor each numerator and denominator. So if I factor a 2 out of this, I get x minus 1. If I factor a 5 out of this, I get x minus 1. And then you just see what cancels. So if I rewrite it, 2 times x minus 1 over x times 2x squared over 5 times x minus 1. I didn't change anything here or here because there's nothing that you can factor out. So the x minus 1's cancel. The x's cancel, just one of these cancels, so I just cross out the squared. And it looks like that's it. So multiply straight across. Remember, numerator times numerator is 4x because it's 2 times 2x. And all that's left in your denominator is the 5. So it's 4x over 5. Okay. To factor each piece first. So I'm going to number them. So number 1, I have to do the roller coaster, which is 1 brave soul to the front, 2 to the back, 1 to the front, 2 to the back, because 1 times 1 is 1. So you want to do loop, loop, and it's going to go right here. 1 times x is just x. Scream or puke, same sign, opposite sign, positive. So this is my new numerator for the first one. In the second one, I need to factor out an x, which is going to leave me x squared minus x plus 1, which you can see is the same as this, so those will nicely cancel. And then 3 is actually already factored, so number 4, you're just going to factor out a negative 30, because then what's left behind is x plus 1, and this x plus 1 will cancel with this x plus 1. So let's go ahead and rewrite it. So I have x plus 1 times x squared minus x plus 1 over x times x squared minus x plus 1 times 3x over negative 30 times x plus 1. So let's see what cancels. X plus 1s, x squared minus x plus 1s, this x and this x, and then you can reduce 3 and negative 30 to 1 and negative 10, because they're both divisible by 3. So all you're left with is your 1 in your numerator and your negative 10 in your denominator. So your answer is negative 1/10. Okay, multiply or divide as indicated. So you need to factor each piece. So 1, 2, 3, 4. So when I factor the first one, I'm going to get x plus plus. Factors of 45 that give you 14 are 9 and 5. So that's my numerator. Now I'm going to factor my denominator. X plus plus. Factors of 18 that give you 11 are 9 and 2. Times, this is going to be 3 and 4. So x plus plus, factors of 6 that give you 5 are going to be 3 and 2. 6 and 1 would also work, but 6 plus 1 would give you 7 here, since both your signs are plus, so you need to do 3 and 2. And then down here we have x and x plus plus, factors of 15 that give you 8 are 5 and 3. So let's see what cancels. My x plus 9s cancel, my x plus 5s cancel, my x plus 3s cancel, and my x plus 2s cancel. So what is your answer? Your answer is just 1. All right. When you are dividing rational expressions, you need to keep it, switch it, flip it. So keep 9z cubed over y to the 5th, switch division to multiplication, and then flip your last fraction so it becomes 5 over 8z cubed y to the 5th. They're all already factored, so you just need to see what cancels. So your z cubes cancel. Looks like that's actually it. So when you multiply your numerators, it's 9 times 5, which gives you 45, and your denominator is 8 y to the 10th, because remember, when you're multiplying like bases, you add the exponents. All right, find the area of the rectangle. So area equals length times width. So the length is x plus 5 over 2x cubed, and the width is 9x over x squared minus 25, which, oops, surprise, surprise, is difference of squares. Okay? So really you have a equals x plus 5 over 2x cubed times 9x over x plus 5, x minus 5. So let's see what cancels. The x plus 5s cancel. This x cancels one of these x's, so this changes to squared. And you're left with 9 in the numerator, and in your denominator you're left with 2x squared times x minus 5. And remember, your answer, I can't fit it over here, but you need to write square feet. Okay? Because you're talking about area. So, or feet squared. Either one is fine. Alright, find the area of the triangle. So, area of a triangle is 1/2 base times height, where this is my base and this is my height. So A equals 1/2, and then my base is 7y over 20x, and my height is 5x over 14y squared. Okay, so you can still cancel up and down and diagonally. So like this x and this x cancel each other. I'm going to switch colors so you guys can see that. This x and this x cancel each other. This y cancels one of these y's. This 7 and this 14 can become 1 and 2. And this 5 and this 20 can become 1 and 4. So you're essentially left with A is equal to 1/2 times 1/4 times 1 over 2y. And when you are multiplying fractions, you just multiply straight across. So A is equal to, if I just do numerators, 1 times 1 times 1 is 1, over, then do denominators, 2 times 4 times 2y is 18y. It's just kidding, 16y. And then you're talking about area, so it's square inches, because they told you over in the problem that it was inches. Okay? Alright, find the LCD of the rational expression. So when we're talking about LCD, we're just going to look at the denominators. When we go to write our LCD, you have to make sure that every denominator is represented. So looking at the numbers, I want the lowest number that all three of them go into evenly. And it's actually 30. Because 30 goes into 31 times, 6 goes into 35 times, and 5 goes into 36 times. And then you want this x represented, so I'm going to put an x here. We already took care of the numbers. I want an x squared represented, so I'm going to have to change this to squared. I need an x cubed represented, so I'm just missing one x here. So instead of squared, I'm going to make it cubed. So your LCD for these three fractions would be 30x cubed. Alright, so before you can find the LCD for this problem, you actually need to factor both denominators. So I've got x and x. It's going to be minus plus. Factors of 5 that give you 4 are 5 and 1. Over here, x and x minus plus. Factors of 6 that would give you negative 5 is going to be negative 6, positive 1. So in order to find the LCD, you need an x minus 5. That's good. You need an x plus 1. So check, check. You need an x minus 6. Check. And you need an x plus 1, but I already have an x plus 1, so I'm good. So that is your LCD. Alright, now we're going to add and subtract the rational expressions. In doing so, you need a common denominator. This one's actually already set up for a common denominator with us, so I can put everything over the common denominator and then just write in the numerator what's left. So 14 minus 10 equals, 14 minus 10 is 4, so your answer is just 4 over 7x squared. Alright, this one they did not give us a common denominator, so we're going to have to go ahead and find the LCD. The LCD is, I'm going to need an r, and then I'm going to need an r plus 1. Okay? So just because there's an r here doesn't mean that that r represents this r. This is r and this is r plus 1. Those are two different things. So I'm going to go ahead and write the whole thing over r times r plus 1, and then compare the individual denominators to see what I'm missing. So what is this denominator missing that this one has? An r plus 1. What is this denominator missing that this one has? An r. So then you have 2 times r plus 1 plus 9r. So if I distribute this, I get 2r plus 2, and then I still have my plus 9r. And this is still over r times r plus 1. And then 2r and 9r are like terms, so you can add those to get 11r. Still have that plus 2, don't forget about that. And it's over r times r plus 1. Make sure you put parentheses so you don't accidentally cancel things that don't need to be canceled. Alright, so you have to find a common denominator first. So you need to factor both denominators. So it's going to be m and m, minus minus, and factors of 6 that give you 7 are 6 and 1. Then over here we've got m and m, m and m, minus minus, and 4 and 1, factors of 4 that give you 5. So I want my LCD. I need an m minus 6, check that off. I need an m minus 1, check that off. I need an m minus 4, check that off. And then I need an m minus 1, which I already have. So I'm going to write everything over my new common denominator. Now I'm going to compare each denominator to the common denominator to see what's missing. So I've got m minus 6, I've got m minus 1, I'm just missing m minus 4. So that's going to get multiplied times the numerator. Parentheses are extremely important here. Here I've got an m minus 4, I've got an m minus 1, but I'm missing an m minus 6. So that gets multiplied times the numerator. So I've got m minus 4 times m minus 5 plus 2m plus 1 times m minus 6. Okay, so you're going to have to double distribute, or some of you like to call it foiling. So m squared minus 5m minus 4m plus 20 plus 2m squared minus 12m plus m minus 6. And this is all over your common denominator of m minus 6 times m minus 1 times m minus 4. Okay, combine your like terms. We've got m squared plus 2m squared is 3m squared. And then you've got negative 5m, negative 4m, negative 12m, and m. So negative 5 minus 4 is negative 9, minus 12 is negative 21, plus 1 is negative 20. Cross all those out. And then you do 20 minus 6 is 14. Cross those out. And this is all over m minus 6 times m minus 1 times m minus 4. Then you want to see if there's anything you can do to factor the numerator. In this case, there is not. So you stop, and that's your solution. Okay? First things first, put parentheses around your binomials. See if there's anything you can do to factor them. The only thing you can do is this last one is difference of squares. So your LCD is going to be x plus 1 times x minus 1. And you already have both of these, so that's going to be the whole LCD. So you have x plus 1 times x minus 1. So looking at this denominator, I'm missing an x minus 1. Looking at this denominator, I'm missing an x plus 1. And I'm not missing anything in the last denominator. So now we need to multiply. So we have 3x times x minus 1. Okay, not sure what happened there, but the video went a little bit crazy. Now you need to see if there's anything in the numerator that you can factor that will cancel with anything in the denominator. So I'm going to say, let me scoot this up. And you've got 3x and 3x. It's going to be plus plus. Factors of 3 that give you 4 are 3 and 1. This would be divisible by 3. So you have x plus 1 times 3x plus 1. So if I check that really quick, 3x squared plus 1 plus 3. Yep. So that actually does work out. So the new numerator is this x plus 1 times 3x plus 1. And then your denominator is still x plus 1 times x minus 1. Your x plus 1's cancel, so you're left with 3x plus 1 over x minus 1. And that is your final answer. Okay, now we're dealing with complex fractions. So the steps are: make your numerator one fraction, make your denominator one fraction, and then multiply by the reciprocal of the denominator. So my numerator is already one fraction, my denominator is already one fraction, so we can go straight to multiplying by the reciprocal of the denominator. So these cancel each other, but remember, anything that you do to the denominator, you have to also do to the numerator. So these x's cancel. 7 and 35 become 1 and 5 because they're both divisible by 7. 7 goes into 7 one time, 7 goes into 35 5 times. And then 4 and 2 are both divisible by 4. 4 goes into 4 one time, 4 goes into 32 8 times. So when you multiply straight across numerators and denominators, you end up with 8 times 5, which is 40, over 1 times 1, which is 1. So your answer is just 40. Okay, so first things first, I'm going to do my parentheses. So 1 and 2 are actually already done for us because this is one fraction and this is one fraction. So we're going to go straight to multiplying by the reciprocal of the denominator. So these cancel, these cancel. Nothing cancels up there, so you're left with x times x minus 7 over 4 times x minus 5. Okay. 1 and 2 are already done for us because these are both individual fractions. So you're going to go straight to multiplying by the reciprocal of the denominator. These cancel, these cancel. Nothing else cancels, leaving you x times x plus 2 over 36. All right, last one. Got 1 and 2. The numerator is one fraction, but do you notice this is difference of squares? So it would be 5q plus 6p times 5q minus 6p, all over pq, because I factored that. All right, now I want to deal with the denominator. I have 5 over p minus 6 over q. So I need the LCD. My LCD is going to be, I need a p and I need a q, so it's going to be pq. Okay. What is missing from this denominator that this one has? Just a q. What's missing from this denominator that this one has? Just a p. So this becomes 5q minus 6p. That's my new denominator. So I'm going to rewrite it. So I have 5q plus 6p times 5q minus 6p all over pq. And this is all over 5q minus 6p over pq. And that's step 3, rewriting it as a new complex fraction. Multiply by the reciprocal of the denominator. These cancel, and then do the same thing to the numerator. And you'll notice the p's cancel, the q's cancel, the 5q minus 6p cancels, and you're just left with 5q plus 6p. And that's your final answer. Your worksheet says 6p plus 5q, but that's the same thing. You guys have a good night, and I will see you tomorrow.